Hello. Hello everyone. Am I audible? Yeah. Okay, just a second. Yeah. Hello everyone. Am I audible and visible properly? Welcome to Deeksha Vedantu YouTube channel. This is our live. This is a very important live for you guys. Okay, let me just wait and let people join. Hi everyone. Everyone who is here, hello Alia. Everyone who is here, I want you to share this live, share the link of this live with your friends, with your cousins who are going to give 10th board exam, because this is a very important live today. I've brought you a very important live which says paper out. It's all the very important questions for you for physics. Okay, hello everyone. I'm just waiting. Clear audio, ma'am. Okay, thank you. I will just join in 1 or 2 minutes. Hi Rohit. We're just waiting for 1 or 2 minutes. How is your preparation going? Are your pre-boards done, or you're about to give your pre-boards, or you're giving your pre-boards? Hi everyone. Let me know in the chat. We'll just start in just 1 minute, okay? Till then, I want you guys to go to our Deeksha channel and see, because today I'm again coming at live at 1 PM in the afternoon, okay? Now this is a very important, why this one is a very important live, because this one will consist of all the PYQs, okay, or most repeated concepts, most repeated PYQs which you will get today. Will do all the basic concept, all the important questions. Then tomorrow we'll apply those and we'll see if all the concepts that we did today are actually useful or not, okay? Was attempting the pre-board question paper of one of my friends who studied in another school. That's great, Rohit, actually. That's really great. Hello, Trev. Pre-boards done. Okay, even if your pre-boards are done, this is still a very important live because your boards are still there, right? Okay, I want you to just go on the channel and like this video and show your attendance that you will come tomorrow, because tomorrow's live will be very important, okay? Okay, can we start? Okay, let's start. Okay, let's move on to our first question, which says, okay, now let me tell you, physics questions were kind of tricky, okay? Let me know if you have any doubts, we'll solve it, okay? Okay, the first, today in this live, we will be covering 2 chapters, that is electricity and magnetic effects of electric current. So let's look at the first question, which says, hi everyone, ma'am, kab hoga live? Live will be tomorrow at 1 PM, okay? Tomorrow 1 PM. Hello Ankit. Okay, let's see our first question. Maybe let me know in the answers if you know the answer to this question. State whether the current and potential difference. Again, I repeat it in every live. Read the question carefully, okay? State whether the current and potential difference in all the bulbs will be same or different when in a circuit 3 bulbs off. Okay, let's read the question carefully. We need to see whether the current and potential difference in our 3 bulbs will be same or different. Let's see their combination. We have 3 bulbs, and in first combination they have same wattage and are connected in series. They are of same wattage and are connected in series. Okay, Alia is saying answer A. My name is Aditi Muhammad. Okay, hello everyone. Okay, let me know the answer. Let's read it carefully, okay? 3 bulbs and they are connected in series and they have same wattage, okay? So they have same. Watt is a unit of kind of what? Power. Abhimanyu, no, you are not late. It's the first question. Okay, if we are given same wattage first, that typically or basically means they have same resistance. Okay, if three bulbs have same wattage, that means they will have same resistance. Then second, same wattage but are connected now in parallel. Different wattage are connected in series. Different voltage connected in parallel. Let me know the answer. Alia is saying answer A. Answer A. A. Okay. Anyone else? Anyone else who thinks answer is B or C or D? I'm waiting, you guys. Okay. Let's do the question. Same wattage, what did I say? Same wattage means same resistance. Now let's say we have three bulbs. Okay, let me make the bulb like this. These are three bulbs, okay, and they are in series. Now if they have same resistance, that is R and R, and we know SI unit, in series current remains same. So I is the current that is passing from all these bulbs. So I is same, R is same, so voltage will also be same. So in first case, why did you answer A? Every part has different answers, okay beta. So I will be same, voltage will also be same in the first part, A question. Let me just clear everything. Okay, in the A part we have bulbs in series and all the resistances are same wattage, that means same resistance. All the resistances are same, that means I and V will be same. Okay, in the second case we have three bulbs but now they are in parallel. See, approach this question very carefully. Now they have same wattage again, that means they have same resistance. If they have same resistance, so, and we know in parallel voltage doesn't divide, voltage stays the same. So voltage we know is same, okay, and if resistance is same, if my resistance is same, then what? V is same, R is same, then current will also be same. Correct? Then looking at the third C part, that will be different wattage are connected in series. So the three bulbs are now in series. So in my series, I remains same. Write the things that you know first. Okay, I is same. Now these are different, R, 2R or 3R. Now if the resistances are different, voltage is same, so current will be different. See, V equals to IR. If my R is here 2R, then this will be I into 2R. Then I will into 3R. So voltage will be different, right? This voltage and this voltage is different. So voltage is different. Correct? And then the D part. Now can you answer me the D part? Good evening. Pinky Rajput. Good evening. Jessica, hello. It must be A. My name is Aditi, Pinky. Why are you guys answering A? State whether the currents and potential. See, listen to the question carefully. They didn't ask you which option is correct. They asked you state whether the current and potential difference in all the bulbs will be same or different when in a circuit three bulbs off. Now read it with it. Three bulbs of same voltage are connected in series. First part. Second part in parallel. Third part different voltage in series. Fourth part different voltage in parallel. So you have to answer for each part. Okay. You have to answer for each part. They didn't ask you in which option there will be same voltage and same current. Okay. So for D, now in D different voltage and parallel. So we know in parallel voltage remains same. Voltage remains same. And if my resistance is different, then current will be different. Correct? Understood the question? Was this tricky? Let me know in the comment section, was this tricky? Trev. Okay, understood the question. Let's move on to the next one. Anyone has any doubt in this question? I'm moving to the next one. Okay, second question, assertion reason. Assertion is, read very carefully if they've asked you option, if they've asked you to answer each part. Okay, a fuse wire is always connected in parallel with the main line. Is this correct or not? Is the fuse wire always be connected in parallel or in series? Answer me in the comment section. Different it was. Am I getting your comments late? D, Alia is saying D. Okay, okay. And the reason says, if a current larger than specified value, if a current larger than specified value flows through the circuit, fuse wire melts. What's the answer? Alia is saying D. Anyone else who wants to counter her? Okay, Abhimanyu was also saying D. Trev is also saying D. Jessica is also saying D. Okay, you all are very, very correct. D is the answer because fuse wire is never connected in parallel. It's always connected in series. Never connected in parallel. Fuse wire is always connected in series. Series with the main line. Next question says, how is electric current related to potential difference? How is electric current related to the potential difference across the terminals of a conductor? This is very easy. A is false and R is true. Correct. Alia is true. Alia is correct. First, let me know the answer of this. How is electric current related to the potential difference? It's very easy. It's the most basic topic of your physics, of electricity. Let me know in the comment section, guys. I'm waiting for your answer. It's very, very easy. Linear. Trev is saying linear. But there's a formula to it, right? Linear what? Yeah, of course you can say linear. But yes, Ohm's law, correct. So, electric current and potential difference are related to each other with the formula V equals to IR, which is my Ohm's law. Then first, now let's move on to the A part, which says, why should an emitter have low resistance? I have also asked you this question multiple times because this is a very repeated PYQ. Okay, almost. Okay, wait guys, let me come to the first and the second part. Okay, the first, okay, you guys want to answer the first part, A question. A part, why should an emitter have low resistance? Write the answer to that question. Don't jump to the second part directly. Can you guys write the answer to? Okay, I'm just explaining, fine. A, why should an emitter have low resistance? So, my emitter, the emitter I have, my emitter is always connected in series with the, in my circuit. Okay, so my current passes through emitter, and what is the function of emitter? Function of emitter is actually to calculate the value of current. Now if my current is passing through emitter and it has very high resistance, so it will obstruct the flow of current and it just needs to measure the current. So all current should pass through the emitter so that it can measure the value completely, right, and accurately, efficiently. But if it gives its resistance, it will obstruct the value of current. If my current is 5 ampere and because of the resistance of emitter it gets 3 ampere, so actual current was 5 ampere but emitter will show 3 ampere, so that's not correct, right? Measure current precisely. Trev is correct. Okay, the B part says, now come to the B part, two VI graphs A and B. Two VI graphs A and B for series and parallel combination of two resistors are shown. Giving reason, state which graph shows series and which graph shows parallel combination of resistances. Let me know your answers. one more thing I want you to take see very carefully is whether V is at y-axis or x-axis or y-axis. Take slope, see, slope of this graph is my resistance, okay, and slope will be perpendicular by base. What is perpendicular here? Current. And what is the base? V. So R equals to I by V, correct? In actual, the Ohm's law we have is V equals to IR, correct? Now whether, okay, let me know if I wrote this correct. Is the slope R or the slope will be 1 by R? Slope will be R or 1 by R in this case. Okay, I'll let you know the answer. That will be 1 by R. Okay, my slope will be 1 by R in this case. Now give me the answer. In series, resistance will add up. That means resistance will increase. If resistance increases and my slope is 1 by R, so the graph which has less slope will be series graph, correct? 1 by R, correct, Trev is correct. So if R increases, but in this graph, in this particular graph, we have V on the x-axis. So instead of slope having R, we have slope equals to 1 by R in this case. See, if you are going to deal with tricky questions, then listen carefully, okay? First, see whether the V or I is at x-axis or y-axis, then calculate the slope. If my slope is, in this case, it's I by V, but technically R should be V by I, correct? So if it's I by V, then R should be 1 by R according to this case, correct? Now R increases in series, R increases, correct? And if R increases, then what will happen? The slope which has lesser, the linear graph which has lesser slope will have more resistance, correct? So A will be what? Series, and B part, parallel combination, will have more slope in this case because the slope is inverse now. Okay, see, if R was series, okay, R series, and RP is the resistance in parallel. Now if I combine some resistances in series, their resistance will increase, and in parallel their resistance will decrease. So according, and this is the slope, so according to that, if high resistance B should be series and low resistance A should be parallel. But in this particular graph case, we have slope not as R but as 1 by R. So our result, our answers will flip, correct? Understood everyone? Got the answer? Okay, let's move on to the next question, that is, in the given circuit diagram, suppose the resistors R1, R2 and R3 have the values of 6 ohm. R1 and R2 and R3 have values of 6 ohm, which have been connected with a battery of 12 volt. This is a 12 volt battery. Now they are asking, calculate current through each resistor and the total current in the circuit. Let me know your answers. Have you all kept your notebook and pen with you? Because this is a physics and it's electricity, so you need your pen and paper with you. Let me know the answer to this question, guys. Current through each resistor. We have voltage, we have all the resistances. What is the first step that I've told you to do every time you see multiple resistances in a circuit? Multiple resistances are there in a circuit. What is the first step that you will use? 2A. What is 2A? Let me know. Clear the board up. Move to the next question. Come on, come on, come on. Do you know the answers to this question? R R equivalent. Very good. The first thing you do when you see a circuit with multiple resistances, what you do? You calculate R equivalent. Now, in this case, we'll calculate R equivalent. They are connected in parallel. They are connected in parallel in this circuit. So, 1 by R1 plus 1 by R2 plus 1 by R3, which will be 3 by 6. So, R equivalent will be 2 ohm. Correct? R equivalent will be 2 ohm. And if my R equivalent is 2 ohm, R equivalent is 2 ohm and the voltage given is 12 volt. So, I can easily calculate the current in the circuit. So, V equals to IR. So, volt is 12, current into resistance is 2. So, I equals to 12 by 2, which is 6 ampere. Correct? So, current in the whole circuit, is 6 ampere. Yes, Alia, I am seeing your answers. A is 2 ampere, 6 ampere. We'll find out. Let's see if you're correct or not. Oh, so for you have given B. See, B, Alia, is correct. B is 6 ampere. That is correct. Now, how will we find? We also need to find the first part, which is current through each resistor. Now, instead of taking R equivalent as 2 ohm, we'll just take one resistor. Let's take the value of R3. Since each resistors have same value of resistances, so you can take any resistor, okay? R3 is 6 ohm and voltage in parallel, voltage does not divide. In parallel, voltage remains same. So, in this, voltage will still be 12 volt. Again, we'll apply Ohm's law. V equals to IR. This is 12. This is current we need to find, and this is resistance. So, my current will be 2 ampere. Correct? Alia was correct. Current is 6 ampere. Correct. Okay, moving, understood the question, understood the answer. Moving on to the next question, which says, oh, I had another slide. Yes. Two identical resistors of 24 ohm each. Two identical resistors of 24 ohm each are connected to a battery of 6 volt. Calculate the ratio of power consumed by the resulting combinations with minimum resistance. Clear? Okay. Can you solve this question, guys? I'll give you some time. Can you solve this question? Two identical resistors. So, I have R1 and R2 as 24 ohm and they are connected to a battery of 6 volt. Now, calculate the ratio of the power. We need to find power consumed by the resulting combinations with minimum resistance, maximum resistance. Minimum resistance and maximum resistance. Okay, so for minimum resistance, we know that we should connect our resistors in series, correct? So my R equivalent for first combination for minimum resistance will be 24 plus 24, that will be 48 ohm, correct? This is correct. Then now I have to find the power and I have voltage. So can I just find power equals to V square divided by R. Now voltage is 6 into 6 divided by R is 48. Can you easily solve this calculation? 24 plus 24, yeah. Can you easily solve this calculation? Are you even there, guys? Okay. Are you even understanding this? 0.75 watt to for maximum resistance and 3 watt for minimum resistance. Trave is sync. Okay. Anyone who's answering? Trev is saying calculation is easy. Okay, so can I leave the calculation? Can you do this calculation? Let's move on to the next part then. So for maximum resistance, we connect. Okay, did I do something wrong? I did something wrong. You guys didn't even tell me. Are you paying attention or not? For minimum resistance, it's not. Yeah, for minimum resistance, it will be not in series, but in parallel. Come on, guys. Okay, let's just... I erased everything. Let's do it again. Okay, for minimum resistance, for A part, let me do this again. For minimum resistance, come on guys, you have to see if I'm mistaking somewhere. I can't understand. Wrong. Yeah, fine. Okay. If you can't understand, listen properly. Oh, minimum resistance, in case of minimum resistance, we need to connect these resistances in parallel combination. Correct? So if I am connecting resistance in parallel, I will do 1 by R1 plus 1 by R2, correct? And it will be 1 by 24 plus 1 by 24, which will be 2 by 24 and hence 12. So R equivalent is 12 ohm. Correct? And then if I need to see power, V square by R, V will be 6 into 6 divided by R will be 12 now. R will be 12. So you will get 3 watt for minimum resistance. Power for minimum resistance will be 3 watt. Okay, now did you understand? So for maximum resistance, we need to connect resistors in series. Okay, for series, we will add the two resistors, which will be 24 plus 24, which will be 48 ohm. Correct? So power now will be V square by R, which will be 6 into 6 divided by 48. Can you do this calculation now? Clear? Let's go to the next question. Wrong. Anju Rawat is saying wrong. Now is it correct? Okay, let's move on to the next question. Sixth question says, in the circuit diagram shown, two resistance wires A and B are of same length. A and B are of same length. Correct? But A is thicker. A is thicker than B. Correct? Which ammeter, A1 or A2? This is A1 and B1 is A2, will indicate higher reading of current. We want to know which will indicate the higher reading of current. Ma'am, your chat is slow. I am joined through laptop as well. I don't know. Let me just refresh once. Okay, do you know the answer to this question? Which emitter, A1 or A2, will have higher reading of current? We need to see which one has higher reading of current. Can you tell me, guys? Refresh it. Yes, I've refreshed it, guys. Hi, ma'am. Hi. What is this name? Ashganj. Okay. A1 will show higher reading. Abhimanyu is saying A1 will show higher reading. A1 will show higher reading. Anyone else who wants to answer? Okay, let's look at the answer. Now, we know A is thicker, which means if A is thicker, that means A has bigger area of cross section. Bigger area of cross section. Where we use area of cross section? We use rho L by A. If my area is more, if my area of cross section is more, that means resistance is less. Correct? If area of cross section is more, that means resistance is less, since R is inversely proportional to area of cross section. Correct? Till here everyone understood? Then if resistance is less, that means more current will pass through that resistor. Because resistance is less, no obstruction in the flow of current, or less obstruction in the flow of current, so current will be more. Where the current will be more? In A, since it has thicker, it is thicker than B. So in A resistor, that is emitter A1, will show higher reading of A1 will show low reading. Alia is saying A2 is higher reading. A2 higher, A1 lower. A1 will show higher reading, right guys? A is thicker, so has bigger area of cross section. If it has bigger area of cross section, then resistance will be less. If resistance is less, that means more current will pass through it. If more current is passing through it, so it will show higher value in my emitter. Understood everyone? A1 will not show low reading, A1 will show high reading. How is everyone else getting A1 lower? I don't know. You guys tell me. What logic did you guys use? I really want to know. How is everyone getting A1 lower? Okay, let's move on to the next question. Distinguish between the term overloading and short circuiting as used in domestic circuits. So, this is a very important question. What it is? Overloading and short circuiting. What does these two terms mean in our domestic circuit? So, let's just look into this. Overloading, have you seen those plugs, multi-plugs? So if you connect in one multi-plug, if you connect your refrigerator, your TV and your laptop and your speaker, so what will happen? Oh, it will lead to overloading. So that one plug, that one single plug is taking in more current than it should. Okay, it requires more current than our wires has, or it should require, and thus it leads to overloading. Correct? And then short circuit just basically means we have three wires in our houses. Correct? That is live wire, the neutral wire and earth wire. If my live wire, that is red wire, and neutral wire, that is black wire, if they come directly into contact with each other, usually what happens, the red wire and black wire basically has some resistance between them. It has some resistance. Like in this case, we talk about our appliances. So we connect our appliances between this red and black wire, and because of that, they are not directly connected to each other. Both of them are connected to our appliance. But if in any case you connect a live wire and a black wire directly to each other, then a huge amount of current will pass and it will lead to short circuit, which can even lead to fires. Okay, so let's look at the answer. The overloading is, it occurs when too many electrical appliances are connected to a single circuit and draw more current than wire can safely carry. Correct? That's what I told you. And then short circuiting means it occurs when the live wire and neutral wire come into direct contact due to damage or insulation failure. Okay, then some more points. The total resistance of the circuit becomes low. In overloading, there are lots of appliances, so all are connected in parallel. If all my appliances are connected in parallel, we know in parallel resistance decreases. Resistance decreases, current increases. Hence, the resistance becomes low because many appliances work together, hence increasing the current. And it causes overheating of wires, may lead to melting of insulation. Why this happens? It happens when high power devices are used together in one socket, and here the current increases gradually. Okay? More than in a short circuit when live and neutral wire touch each other, overloading too many. Correct. Ampere ज़्यादा हो तो causes fire, yeah. What about high? When current will be too much, it can lead to even fires. Okay. In short circuit, the resistance becomes almost zero because live wire and neutral wire are connected to each other. So resistance becomes almost zero instantly and cause a sudden surge of current. It provides a very large current suddenly, which can cause sparks, fires, damages to appliances, and it usually happens due to broken wires. My live wire and black wire, neutral wire is connected, so usually they can be broken, they can be damaged, and in this current increases instantly and violently, which can cause again fire. Okay, you can take the screenshot. Just a second, I'll erase all the ink. Yeah, if you want, you can take the screenshot. Okay, let's move on to the next question, which says a wire of length L. A wire of length L, resistance R is stretched so that length is doubled. Now the length is 2L, correct, and area of cross section is halved. So area of cross section is halved. How will the resistance change? First question, how will the resistivity change? Let me know the answer. Javin Sharma, hello Javin Sharma. Let me know the answer to this question. If I have a wire of length L and area of cross section A, if I stretch it, its length becomes doubled, area becomes half. What will happen to its resistivity and what will happen to its resistance? How will these two change? R dash equals to 4R. Okay, Alia is saying the new resistance will be 4 times its previous resistance, correct? Is that what you are saying? No change in resistivity. Swati is saying there will be no change in resistivity. Okay, both of you girls are very correct. If I see the resistance in this case, it will be rho L by A, correct? In this case, let's say it R1. Here my resistance is 2L and my area is A by 2. If I solve it, it will be R1 equals to 4 into rho L by A, correct? And that will be 4 times R1, 4 times this previous resistance. So my new resistance will be 4 times the previous resistance. And since the wire is same, we know for the same wire or for the same material, resistivity does not change. Resistivity, because resistivity is just a property of material, does not change. Correct? Resistance becomes 4 times, resistivity stays the same. Darshan, hi. Class 10th AIR 1. Low voice. Am I not audible? Resistivity remains unchanged. Okay, everyone is correct. Let's move on to the next. It says 3 2 ohm resistance. 3 2 ohm resistors A, B and C are connected as shown in the figure. Each of them dissipates energy and can withstand a maximum power of 18 watt. The maximum power they can have is 18 watt without melting. Find the maximum current that can flow through the 3 resistors. Can you answer this question? Okay, thank you, Alia. Voice is okay. 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 Focus on the question. Very important question. There are 3 2 ohm resistors. You can see they are connected in this certain way, and the maximum power they can have is 18 watt. Then what will be the maximum current that we can pass through these resistors so that they don't melt? Okay, someone who's saying, Alia is saying 3 ampere. Okay, 3 ampere. Yeah, I saw your answer, Alia. Anyone else? Are you guys solving this question? It's a very important question. Listen carefully. What is the maximum current that can flow through these 3 resistors? Okay, first, what will we do? When we see different combination of resistors, we'll find the R equivalent. That will be 2 ohm plus this is in that parallel connection, right? So 1 by 2 plus 1 by 2, that will be 1. So 2 plus 1 equals to 3 ohm. Correct? So if I use the formula I square R, and R is 3 ohm, I square, and this is 18, so I square will be 18 divided by 3, which will be then 6. So I equals to root 6 ampere. Correct? Something 2 point around. Correct? Why are you guys getting 3 ampere? Did I do something wrong? Power is 18 watt. मेरा तो अलग आ रहा है. Yeah. Okay. Power is, so if for the whole circuit we are saying current is same. Current will be same in this and current will be same in this whole circuit. फिर से check कीजिए. Let me check again. If we do it without calculating the whole, wait a minute. If I just use the 2 ohm resistor, so resistance is 2 ohm, and if we just see, okay, let's see the power in this question. Okay, you guys are calculating separately. Correct. Power is 18 watt. If I do like this, then this power will be just for first A resistor, then I will get the answer you are getting, that will be I square into R is 2 and this is 18. So I will be 18 by 2 square. So here, yes, I will be 3 ampere. Fine, you can do like this too. Yeah, if you can. See, if in series current does not divide, so you can calculate for A separately and you can calculate for this whole circuit separately. If they have given, find the maximum current that can flow through these 3 resistors. If they are asking to flow these 3 resistors combined, then you have to find R equivalent first. Then R equivalent will be 3 ohm. Correct? So instead of using 2 ohm, you'll have to use 3 ohm since they've asked the maximum current through the 3 resistors. Okay. मैम 2000 दुनिया में दुनिया खत्म है यही सोचकर पढ़ नहीं रहा हूँ. बेटा 1% चांसेस है भी दुनिया रह गई तो फिर बुरा हो जाएगा. Is all questions from electricity. Today the questions will be from electricity and magnetic effects of current. Okay, let's move on to the next question. What would be the reading of ammeter and voltmeter in this given circuit? Again, the first rule is to find equivalent resistance. The first rule is always to find equivalent resistance. So find the equivalent resistance. No, power is not given of combined resistance. See, in See, each of them dissipate energy and can withstand maximum power of 18 watt. So read the question carefully. Okay, 1 ampere and 2 volt. Alia is saying you are fast. Okay, let's do the question. First is equivalent resistance. These two resistances are in series, so equivalent resistance will be 3 ohm. And we have voltage as 3 volt. The question is easy, so we can just use Ohm's law. This is 3 current and 3 I will be 1 ampere. Okay, and voltmeter. Now see carefully, if the voltmeter is just connected to 2 ohm resistance, we are not measuring voltage across 1 ohm, and since these two are in series, voltage will be different for 1 ohm as well as 2 ohm, correct? Since these are different, so I've calculated the current. Now current will be same since it's resistance, so current is 1 ampere. My resistance is given, which is 2 ohm. So again I'll use Ohm's law and calculate voltage across 2 ohm resistance, which will be 2 volt. Correct? Understood? Okay, hello, Darshan, hello. Okay, correct? Understood everyone? The question, it was easy. You just need to know when the current divides and then when the voltage divides. Okay, next question. I want you all guys to go and follow the link in the description and go to our WhatsApp channel and join that WhatsApp channel, because you will get notification for all the lives, all the stuff that we are doing to help you in your boards. There is a link in the description, so go and check that. Okay, answer, I gave you the answer, 2 volt and 1 ampere. Okay, let's move on to the next chapter, which is magnetic effects of electric current. Let's see the question. A student named Ria, why did I circle Ria? Okay, is conducting an experiment using a coil wound around a long hollow cardboard tube connected to a battery. Demonstrate the concept of electromagnetism. Okay, so there is a girl, Ria, who took a wire, wrapped it around a hollow cardboard to demonstrate the concept of electromagnetism. Correct? Show the polarity acquired by each phase of the solenoid. Now this is my battery. Can you see? If you can't, this is negative and this is positive. Now let me know if A will be north or B will be north. What will be A and what will be C? Will A be north or south, or will B be north or south? Let me know. Is this a solenoid, ma'am? Yes, correct. It's a solenoid. Let me know. Will A be north or will B be north? Will A be south or will B be south? Anyone knows the answer? Anyone? Okay. A north, B south. Jessica is saying A north, B south. Correct. A will be north, and B will be south. How can you remember this? Negative terminal will be north. Correct? N. Negative terminal will be north one. Correct? A will be north, B will be south. So first is done. Draw the magnetic field lines of force inside the coil and show their direction. Now we know, if I just draw this solenoid, it is a solenoid and this is negative, so this will be north and this will be south. Now we know the magnetic field lines inside a solenoid is just like a bar magnet. So I will draw these kind of magnetic lines. These will be my magnetic lines around the solenoid or inside the solenoid. They should not touch each other, and their direction will be outside north to south, outside north to south, and inside south to north. Correct? outside their closed loops from A to B. Correct. Correct. Jessica. Was it Jessica? Alia. It's correct. It's hard to type. It's fine. You will get the fruit of this, your hard work. Okay, correct. Then the third is mention two methods to increase the strength of the magnetic field inside the coil. Now we have a coil and we want to increase the strength. We want to increase the strength of magnetic field inside the coil. How will we increase the strength of magnetic field inside the coil? Who is going to answer? Who will answer? How can we increase the strength of magnetic field inside this coil, inside the solenoid? Soft iron. If we want to increase the strength of magnetic field, there can be two options. To increase the strength of magnetic field, we can either increase the number of turns, of this coil, okay, or second, we can increase the current. We can increase the value of current. Correct? Let's move on to the next question. This says state the factors on which the resistance of a cylindrical conductor depends. How will resistance of a conductor change if it's stretched so that now its length is doubled? L1 was L, we stretched it and now its length is doubled. How will the resistance be affected? Increase number of turn, increasing coils. Correct. Alia, you are correct. Okay, today is my birthday. Vishal is saying happy birthday, Vishal. I hope you have a good day and I hope you ace in your 10th class boards. Okay, state the factors on which the resistance of a cylindrical conductor depends. Now we know the formula for resistance is rho L by A. So the factors are length of my conductor and area of cross section. And if you are a good bacha, you can write that it also depends on the material of conductor, that is resistivity. Material of conductor, this is not really necessary, but you can write it, that is resistivity. If my length doubles, then resistance will be now rho into 2L divided by A. So R will be rho. Since okay, see, it is being stretched. If it's being stretched, length will increase, but length will increase, but its area will decrease. Correct? If I have a wire, if I stretch it, its length will increase, but the area of cross section will decrease. Correct? So this will also become A by 2. So R will be 4 times. New R will be 4 times the previous R. Okay? So my resistance will become 4 times. Okay? Correct? Depends. Yes, I am seeing your question, beta. I am seeing your. Alia is saying length, cross section, correct, nature of material and temperature. You can write it. But if you are writing temperature, you should know how it exactly depends on temperature. Okay. If a conductor is stretched so that its length is double, its resistance becomes 4 times. Correct. Alia, you are correct. Okay. Moving on to the next question. Magnetic field lines are shown in the given diagram for a current carrying solenoid. Now it's given that it's a solenoid. Correct? Then a student makes a statement that the magnetic field at point P inside the solenoid is stronger than at point P outside the solenoid. Okay, I think there is some problem in this whole diagram. It's saying that P is actually inside the solenoid. P is inside the solenoid, maybe somewhere here, and Q is outside the solenoid. So, and he is saying that the magnetic field at point P is stronger than point Q. Is it correct? Let me make this again. Maybe this is a solenoid, and if I make the field lines, it will be something like this. Correct? North, south, north to south, south to north, north to south, south to north. Now, that bacha is saying that there is a point P inside and there is a point Q outside, and is saying that at point P strength of magnetic field will be more than at point Q. Is he correct or not? Yes, it's correct. KRK is saying correct. Alia is also saying it's correct. Anyone else? KRK is saying wrong figure, because point P inside the solenoid and inside the solenoid have the greatest magnetic field and uniform. Okay. Alia is saying that the student's claim is correct. So, inside a solenoid, my magnetic field lines are uniform. Okay, they are uniform. But outside, they are going far away from each other. Okay, they are going far away from each other. Oof, I cleared everything. Yeah, inside a solenoid, my magnetic field lines are uniform, but outside they are going away from each other. So inside magnetic field will be more and will be uniform, but outside Q will be away from the magnet, so the magnetic field will be less. So student is correct. The diagram should be redrawn with straight parallel lines inside the solenoid. So the magnetic field lines inside the solenoid. Yeah. Correct. Alia is correct. The direction outside is from north to south. Okay. Let's see. Explain with reason. Correct. Also redraw the diagram. They have asked you to redraw the diagram. Also redraw the diagram and mark the direction of magnetic field lines. If this is my solenoid and this is north and this is south, then this will be, we know the pattern, we know the, pattern of magnetic field lines. We just need to show them where the direction of these field lines, they won't intersect. Okay, so outside it will be north to south, inside it will be south to north. Correct? The direction of the, yeah, correct. Biology will be taught by Jasmine Ma'am in, I guess, this week or maybe next week. You can check the schedule, go follow the WhatsApp channel. Next question, 14. What is meant by magnetic force? What is meant by magnetic force? Can anyone tell me? What is a magnetic force? Name and explain the rule to determine. Okay, we'll see. What is a magnetic force? Okay, everyone. Focus on the question. Your typing skills are great. You are not copying from AI. Even if you are, see, even if someone is copying from AI, I'm not telling you are, but even if someone is copying from AI, it's still getting memorized in their head. Correct? So, okay. The answer to this question, magnetic force. So, let it be magnetic force. See, magnetic force is a force experienced by either a current carrying conductor or some charge that is placed inside a magnetic field. If my charge or my conductor is placed inside a magnetic field, this is my magnetic field and maybe this is my magnetic field, then the force that this charge or this conductor will experience, or a magnetic material, let's say iron core or iron, the force that these materials will experience will be called a magnetic force. Okay? Correct? Let's move on to the second part, which says name and explain the rule to determine the direction of force. We need to see the direction of force experienced by a current carrying conductor in a magnetic field. So we have a current carrying conductor inside a magnetic field, and they are asking where that force, how will we find the direction of that force? Okay? How? Which rule? There are two rules in your syllabus right now, right hand rule and a left hand rule. Which rule will you follow to find out the direction of force on a current carrying conductor inside a magnetic field? Focus on the questions. छुटकू चैटिंग कर लोगे, अभी क्वेश्चन करो. ओके, विच राइट हैंड रूल. हेलो मैम, आप कितने साल के हो? मे बी, आई डोंट नो. यू शुड नेवर आस्क अ वुमन हर एज. Focus on the question. Right hand rule or a left hand rule? Right hand rule. Okay, maybe you can think again. Okay, I've told you in the last live as well. Okay, force. We need to find the direction of force. Is yellow color visible to you guys? No, I'm not calling you chutki. I was calling you all chutkus. Okay, force from F. You can remember it's Fleming's. It's Fleming's left hand rule. To find the direction of force inside for a current carrying conductor placed inside a magnetic field, you will use Fleming's left hand rule. Correct? 28 years. Okay, no, it's not right hand rule. Fleming's left hand rule. For right hand rule, we use right hand rule to see the direction of magnetic fields. If this is my conductor and current is upwards, so I use right hand rule. The curl of the fingers will give the direction of magnetic field. For Fleming left hand rule, I will use this. This will give force and this will give magnetic field, and this is current. So my thumb will give the direction of force, my forefinger will give the direction of magnetic field, and my middle finger will give the direction of current. Correct? Okay, if I'm 40 years, then you are a dada. Okay, moving on. Okay, we have more question. How does this force gets affected on doubling the magnetic current? We want to see how will this force be affected if I double the magnitude of current. Double the magnitude of current. If my current increases, it's very obvious that the force will also increase. Okay, if they are in same direction, but right now you can write it's in same direction. Okay, then the second part is reversing the direction of current flow. See, I told you the first part. Okay, if we reverse the direction of current. What do you mean by that? That in my conductor, if current is going upwards, what will happen if my current will start going downwards? Then the direction of force will also reverse, but the magnitude will remain same. Direction of force will also get reversed, but the magnitude remains same. Then the third part is reversing the direction of magnetic field. If we reverse the direction of magnetic field, then also the force will get reversed. The direction of force will be reversed. Correct? Okay, next question says, study the diagram given below and answer the questions that follows. Why do the iron fillings arrange in such a pattern? This is a bar magnet and they are asking, and this is a very repeated question. Almost a lot of the times they have asked this question. It's the most repeated question of this chapter, okay? Why do the iron fillings arrange in such pattern? First we'll do the questions, then I'll answer all your questions, okay? Where I am from, how old I am, but first you answer me these questions, okay? Because of magnetic field, Jessica is saying, because of magnetic fields. And anyone else? I want you guys to like this session, come on. We are done with 15 questions and all the teachers are putting so much effort. Go like this session, okay? Because of field lines, okay? So this magnet is typically a bar magnet, and we know the field lines or the magnetic field around a bar magnet is something like this, which we also find from the experiment where we sprinkle iron fillings around the bar magnet. So the bar magnet, the iron fillings arrange themselves around the bar magnet in the direction or in the pattern of magnetic field lines, which are imaginary lines which depicts magnetic field around the pattern of magnetic field around my magnet. Correct? Yes, due to field lines. Okay. The second question they ask is, what does this pattern demonstrate? So again, this pattern demonstrates the pattern of magnetic field lines around my magnet. Okay, this pattern depicts the pattern of magnetic field lines around the magnet. Correct? Next question, why do the iron fillings near the bar magnet seem to align in the shape of closed curves? See, मुझे नहीं समझ में आया. Okay, so we have a bar magnet. Correct? This is North Pole, this is South Pole. We know that the magnetic fields, we learned it in our class, the magnetic fields go around this in closed loops around the magnet, inside south to north, outside north to south. So in the same manner, if I sprinkle my iron fillings around the bar magnet, they will align themselves according to the pattern of magnetic field. Real paper. What's real paper? Okay. Why do iron fillings align in closed curves? Now they've asked. Because in this particular question you have to write, because the magnetic field lines around a magnet, or in this case a bar magnet, are closed lines. They travel outside from north to south, inside south to north. They form closed loops, and hence the iron fillings also align themselves in a pattern that shows it's a closed loop. Okay, next question says, PQ is a current carrying conductor. This PQ is a current carrying conductor in the plane of the paper as shown. Find the direction of the magnetic fields produced by it at points R and S. The direction of magnetic field at R and S. Can you tell me the direction of magnetic field lines at R and S? at R and at S. Okay, let me just tell you this, the direction of current is in upward direction. Now tell me the direction at R and S. Can you guys tell me the direction of current, direction of magnetic field at R and S? Okay, so to find the direction of magnetic field line, we will use right hand thumb rule, correct? Now current is upwards, so the finger will curl like this, and at this point it's going inwards. The magnetic field lines are going inwards at point R, and at point S they are coming out. So at S they are coming outwards, correct? For outwards we use a single dot just like O. For inwards we use a star. Okay, right hand thumb rule, very correct. Okay. Okay, given R1 is greater than R2, where will the strength of magnetic field be larger? Will the magnetic field be larger at R or at S? Now we know the strength of magnetic field is inversely proportional to distance from the conductor. Since R is away, so the strength will be less at R and more will be at S. Correct, Alia is correct. The strength will be larger at S, the direction of magnetic lines. Okay. If the polarity of the battery connected to the wire is reversed. Second is, if the polarity of the battery connected to this wire is reversed, how would the direction of magnetic field be changed? If I switch the terminals of my battery, here negative, here positive. If I switch it, now here is positive, here is negative. So the direction of current will be reversed, and hence the direction of magnetic lines will be, field lines will be reversed. Correct. Third is, explain the rule that is used to find the direction of magnetic field for a straight current carrying conductor. Now we know this is a right hand thumb rule. To find force, to find direction of force, we use Fleming left hand rule. Correct? From force, F, Fleming left hand rule. For direction of magnetic field lines, it's right hand thumb rule. Okay, next question says, draw the magnetic field lines. Draw the magnetic field lines including the direction of the magnetic field due to a circular coil of current. So this is my circular coil of current. Okay, now let me say this is current going upwards and downwards. Just let me know which rule, which thumb rule we will use to solve this question. Which thumb rule we will use to solve this, to see the direction of current? Let me know which current which thumb rule will we use? Correct, right. Alia is saying right hand thumb rule, Jessica is also saying right hand thumb rule. Let's use it. Here we have current, and I'll curl my fingers in the direction of, so that will give me the direction of magnetic field lines, and these are concentric circles. So this will go inwards, and outside the coil they will come outwards. Correct? In here, this is current, they are coming downwards. Now here also concentric circles, but the magnetic field lines are going inwards. Inside the coil it's going inwards, and here it will come out. Inside the circle, outside the circle. Correct. Let's move on to the next question. Next part, which says, name any two factors on which the magnitude of the magnetic field due to this coil depends. Name any two factors on which the magnitude of magnetic field depends. Let me know two factors. There will be two, yeah, three maybe. Can't draw in chats. It's fine. It's fine. I'll draw for you guys. Okay. Let me know two factors. Two factors on which the magnitude of magnetic field turns of coil and radius of coil. Okay. Turns of coil is kind of correct, but it will be more correct in solenoid part because you are wrapping the coil around the solenoid. But in case of circle, its first very basic is current. If you increase the current, magnitude of magnetic field will increase. And the second is correct, that is radius of coil. Radius of coil. Current is directly proportional, radius of coil is inversely proportional. Correct? Moving on to the next, that is answer the following questions. What is the direction of magnetic field lines outside a bar magnet? Very easy. Let me know. What is the direction of magnetic field lines outside the magnet, outside the bar magnet? What is the direction of, this is very easy, I'll not wait. The bar magnet we have north to south, and outside the bar magnet it will be north to south. North to south. Okay, the magnetic field lines in a given region are getting crowded. What does it indicate? North to south. Jessica is saying north to south. Correct. They are getting crowded. If lots of magnetic field lines are there in one particular region, what does that mean? What does that mean? Let me know in the comment section. If lots of magnetic field lines are there in a single region, let's say this is my magnetic field lines, but on the other region this is my magnetic field lines. So what is the difference in these two? Stronger magnetic field. Correct. If there are too many magnetic field lines in a single region, that means that region has strong magnetic field. Correct. Third is, state one advantage of AC over DC. Can you tell one advantage? AC voltage can be easily stepped up or down using a transformer. Okay. AC can travel safely over long distance. Okay. Everyone can write and you will have more than one. What do you say? Advantages. You will know more than one advantage. One is can travel distances. DC current flow in one direction. Jessica is saying AC voltage can be easily stepped up or down using a transformer. Okay, these are the answers. So basically you can write that in AC there is less power loss during transmission over long distances. Correct? Fourth part says, when a current flows through a straight conductor, a magnetic field is produced around it. How the direction of this magnetic field be determined? See, these questions are again repeated a little bit. Okay, so you can just learn to find the direction of magnetic field. We use right hand thumb rule. Correct? Next question is, which of the following statement is not correct? Okay, this is just an MCQs, you can give answers. Magnetic field lines form a continuous closed curve. Magnetic field lines form a continuous closed curve. Magnetic field lines do not intersect with each other. Direction of tangent at any point on the magnetic field line curve gives the direction of magnetic field at that point. Or D part, outside the magnetic field lines go from south to north of the magnet. Which one is not correct? Yeah, which one is not correct? Answer is D. Alia is saying answer is D. Outside the magnet, magnetic field lines go from south to north. It is correct. We know outside the magnet, it goes from north to south. Inside, it goes south to north. One more question left. The resultant magnetic field at point P is situated midway, which is situated midway between two parallel wires which are placed vertically, each carrying a steady current I. Inwards to the plane of paper at P, you need to find the direction of magnetic field. In the same direction as the current in the wire, 0 or outwards the plane of the paper. In this wire, current is upwards. In this wire, current is downwards. Use the correct rule. Which is the correct rule that you will use to find the direction of magnetic field lines? Magnetic field. Let me know. Alia is saying 0. Okay. Maybe see carefully. The direction of current is upwards in this wire and it's downwards in this particular wire. Which rule will you use? Let me know first that. Which rule will you use? Which right hand or left hand rule will you use to find the current? Come on. Okay. Right hand thumb rule. Let's use the right hand thumb rule. So in this, current is upwards. If I curl my fingers like this, then in here at point P, it will be something like this. It goes inwards due to this left wire. The current, the magnetic field lines goes inwards, and in this here the current is downwards. If the current is downwards, my finger curls like this, so it also goes inwards. It is also going inwards. Correct? Any doubt? It must be 0. See, current is upwards, direction of magnetic field lines like this, so it's going inwards. Can you see? It's going inwards. Can you see it? It goes inwards. So here it goes inwards. If my direction of current is downwards, again they are going inwards at point P. They are going inwards. So these two will add up. See, there is a similar kind of question, but in that question both the current was in upward direction. So if you do like this, it's going inwards, and here it's coming out. It's coming outwards. So that's why these two get cancelled, because it's equidistant from both the wires. That's why these get cancelled and the result is 0. But now I flipped the question. Don't cram the question. I have checked it again, Alia. It shouldn't be 0. I explained you. Don't cram the question. This is my current in upward direction. The field is inwards. The current is upward direction. The field is outwards. So that's why it gets cancelled. Here the current is upwards. My magnetic field lines is inwards. The current is downwards. Again, my magnetic field lines are going inwards. So these two will add up. Okay. Mr. Mukhlal, hello, good evening. Okay, now did you understand the question? Don't cram the question. Use the rule. Inwards. Correct? Now, so the answer will be inwards to the plane of paper. A will be the correct answer, not 0. Okay, understood? Any doubt? If you have any doubt, you can ask me. Okay, we are done with all these questions. Again, I want you to join this WhatsApp channel for all the notifications, for all the news about what we are putting out on channel, and we are going to come up with a crash course for you guys. It will be completely on YouTube. It will be completely free, where we'll completely focus on your boards. We want you to have this thing that we have getting a free crash course, because I know you guys need it. We will revise the whole syllabus of 10th, whole syllabus of boards. You will have exams, you will have multiple live sessions, PYQs, most expected questions, everything in just a single crash course. Ma'am, this chapter is so easy. Okay, that is great. If you think this chapter is easy, that is tremendous. Okay, and of course, I want you to subscribe the channel so that you don't miss anything from our live sessions, from our crash course that we are going to bring on YouTube. And that is it for this live session. Doubt clearing, we are like that WhatsApp channel is basically for notifications and to ask you guys what you want, and we will have doubt sessions on YouTube as well. If you want to ask any doubt, there is no need to message and stuff. We are coming live every day now, every day multiple lives. So 2 lives I guess every day. Today we had a live of SST at 1 PM. Now physics. Tomorrow I'll again come live at 1 PM. You can ask your doubts live only. There should be a link in the description. Yeah, there is a link in the description. You can just click on that link and go join the WhatsApp channel. Okay. इतनी जल्दी खत्म 6:30. I think you guys need some break. My voice needs some break. We'll come again. I'll come again tomorrow. Don't look for questions. Don't sit for 3-4 hours and do the questions. Study different subjects. There are multiple subjects in your 10th. So go revise those. I'll come again tomorrow. We'll again do lots of questions. And I'll come again live on Friday and Saturday as well in this week. Okay? Anything else? Anything else, guys? Tomorrow again, do you want the questions from, see, today we did so many questions, we practiced so many questions. Tomorrow, from these 2 topics, we'll do PYQs so that it fits in your brain completely. Okay? And then the next live that will be on Friday, we'll do same thing for light as well as human eye. And then on Saturday, we'll do PYQs. Correct? So that it gets engraved in your brain. Okay, bye guys. Have a good day. Prepare for boards well, but don't forget to have some fun with it. Okay, there is a link in the description. There is a link in the description to join the WhatsApp channel. मुझे सर्दी लग गई. Probably the weather is changing. Yeah, आपको सर्दी लग गई. Okay. Bye. Okay, bye guys. See you in the next live session, that is tomorrow. Ta-ta.